Hi there. In this video, I want to start talking about vectors plotted on a Cartesian plane. So, oftentimes what we find is vectors can be analyzed and added, subtracted, what have you, very effectively by putting them on a grid system. And the grid system that we're used to using is called the Cartesian plane. I've drawn out a little XY axis here. Not quite symmetrical, but it serves the point. And we can plot vectors on this plane by establishing coordinates for their head and for their tail. So let me give you an example. I could draw a vector that has a tail at this point right here. Okay, and I'll draw it in right there. And it might have a head at this point right here. So the vector would have a tail at the point, okay, so counting on our grid, -1, -2, -3, -4, -5, -6, -7, 2. And it would have a head at the point -3, 1, 2, 3, 4, 5. So that vector would look something like this. I'll draw it with a ruler. And since the vector, okay, so we'll draw it there. And we will put an arrow at the end right here. Just like that, if I can. Okay, there we go. So that vector that you see right there goes from the point -7, 2 to -3, 5. Now, what we're interested in vectors, though, is what makes up the motion and direction of the vector. So we could call this vector A, and what we are really interested in vector A is what does vector A do in terms of its components? Where does it go? Where does the vector go? Because that's what we really need to establish. We need to say, what kind of direction and magnitude does this vector have? So to figure that out, if we want to figure out the components of vector A, what we actually need to do is figure out how much displacement takes place in both the x and y direction for vector A. So vector A components consist of the x displacement and the y displacement that is visible in the vector. And the way that we can get those components is we can just take the head of the vector from an x perspective and see how much it has displaced from the y, or the from the tail of the vector, sorry, which is the x1 component. So in other words, a vector starts out at x1 and goes to x2. So x1 would be its tail, and y1 would also be the y coordinate of its tail, and it goes to its head right here. So what we see here is we have x2 minus x1 comma y2 minus y1, and that will make up the components of the direction in which our vector moves. So doing that, what we can say is that vector A actually has components of, okay, so moving back here, remember that x2 minus x1 was actually -3 minus -7, and y2 minus y1 was 5 minus 2. So what we actually have for vector A is 4, comma 3. So what that means for us is that if I draw a vector anywhere on this grid that displaces 4 units to the right and 3 units up, then I will have a vector that's equivalent to vector A. So let's say I just start at this point right here, and I go 4 units to the right, so 1, 2, 3, 4, and 3 units up, 1, 2, 3, and draw an arrow there, and then I take out my ruler and connect those 2 points. What I actually have is I have a vector whose components match that of vector A. We could call that vector B, but one thing we would definitely want to be clear about is that vector A is equal to vector B. Both vectors go right 4 units, 1, 2, so 1, 2, 3, 4, and go up 3, 1, 2, 3. You can see the same thing in the case of vector B, 1, 2, 3, 4, 1, 2, 3. So vector A is equal to vector B. They're equivalent because they have the exact same displacement. So the displacement of vector A and vector B is 4, comma 3, regardless of where they actually start. In the case of vector B, its endpoint is, or its head, I guess, is 1, 2, 3, 4, 5, 6. And the y-coordinate is 1, 2, 3, 4. And its tail is at 2, 1. But its actual displacement and the components that describe its maneuvering is 4, comma 3. Okay, that's what describes it. And the last thing I want to discuss in this video is what we call a position vector. A position vector is a vector that starts at the origin and displaces by a certain amount. So if I wanted to draw an equivalent position vector for vector A, all I would do is I would just draw vector A from the origin. So I would just start at the origin, and then I would move 4 units right, and then 1, 2, 3 units up, and I would just draw vector A as a position vector, which means that the vector starts at the origin. And once again, I could call that vector A, I could call that something else, because it's equivalent. It is equivalent. But I think that's the last point I want to end off on, is that a position vector, I'll write it over here, a position vector is a vector that starts at the origin and then it goes to some origin, and then it just goes to some predetermined point, okay? All right, so that was just a little bit of a introduction to plotting vectors on the Cartesian plane. We will be doing a lot more of that, okay? So this is just a basic introduction, and the things that you want to get out of this video are essentially this. You want to get out of this video the idea that when you plot a vector on the Cartesian plane, what you'll find is that the tail will have some kind of coordinate describing it, and the head will also have a coordinate describing it. And the displacement of the vector can be found by taking the x-coordinate of the head minus the x-coordinate of the tail, and then the y-coordinate of the head minus the y-coordinate of the tail. So I'll write that down for you right now, actually, just so we can make sure that we are clear on that idea. Because it is an important idea to find the displacement of a vector on the Cartesian plane. Use the following formula. And I'll move this over so we can see. Okay, the formula we will be using would be x2 minus x1, comma y2 minus y1. And that will give us the vector displacement. Okay, and then once we know that displacement, we can change that into a position vector. So if we know, for example, that a vector turns out to be 4, 3, well, we can then put that vector anywhere we want to on the Cartesian plane, but I could turn it into a position vector by putting the tail at the origin and then displacing it 4 units right and 3 up, okay? So a position vector must start at the origin, and then you apply its displacement from the origin. It's a lot of concepts. We'll continue to work on this as time goes by. Thanks.